In this video, we covered page 6 of your section 2.2 lecture notes. Back on page 2, we defined the 6 trigonometric functions of the angle theta using a circle with a radius of 1 unit. And so, we came up with sine theta is equal to y, cosine theta is equal to x, and so forth. And that was based on the idea that this circle, right, has a radius of exactly 1 unit. Now we're asking what sine theta, cosine theta, and so forth equal to if the radius of the circle is a number different than 1. So here we have the graph of a circle, center at the origin, and the radius of this circle is not 1 unit, it's r units, okay? So r is some number different from 1, okay? It's greater than 0, but it's not equal to 1, okay? And you can see that where the circle crosses the an axis, right? It's not, r doesn't equal 1 in that case, all right? So the equation of this circle is x squared plus y squared equals r squared. On page 2, when the radius is 1, r squared is equal to 1, okay? So if we're using a circle with a radius different from 1, how does that affect our definition for the 6 trig functions for the angle theta drawn in our graph here, right? Angle theta in standard position. Well, sine theta, instead of it being equal to y, it's now equal to y over r. And cosecant theta, right, the reciprocal sine is now r over y. Cosine theta, instead of being just equal to x, is now equal to x over r, and secant, the reciprocal cosine, is r over x. Now tangent and cotangent are unaffected by the size of the circle, the radius of the circle. Tangent still y over x, and cotangent is still x over y. So let's demonstrate how to find the exact value of the 6 trigonometric functions of theta, okay, when the circle has a radius different from 1 unit. So in the exercise at the bottom of page 6, we have a point on the terminal side of an angle theta in standard position, has coordinates -1, -2. -1 is the x coordinate, -2 is the y coordinate. We have to find the exact value of each of the 6 trigonometric functions of theta. Well, so here I've drawn the angle theta in standard position, right? Here's the initial side. Here's the terminal side of the angle. And the point -1, -2 is in the third quadrant. So the terminal side is going to go through that point. And there is some circle, right, centered at the origin that passes through that point, okay? And so it's got some radius. So we need to know what r is to calculate what sine theta and cosine theta, right, and so forth are equal to. Well, from the equation up above, right, the equation of the circle is x squared plus y squared equal r squared. We know what x and y are in this case, right? X is equal to -1 and y is equal to -2. So substituting for x and y in the equation of the circle, we end up with r squared is equal to 5, and when we take the square root of both sides, we get the radius r is equal to the square root of 5, okay? So r squared is equal to 5, and so r is equal to square root of 5. Well, now that we know what x, y, and r are, we know what the exact value of sine theta, cosine theta, and so forth are equal to in this example. Sine theta is equal to y over r. Y is minus 2, r is root 5. So sine theta is equal to minus 2 over root 5. Cosine theta is equal to x over r. So it's equal to minus 1 over root 5. Tangent theta is equal to y over x. Y is minus 2, x is minus 1. And so minus 2 over minus 1 is 2. Cosecant is the reciprocal of sine. And so the reciprocal of sine is minus root 5 over 2. Secant is the reciprocal of cosine. And so secant is equal to minus root 5. And cotangent is the reciprocal of 2. And the reciprocal of 2 is 1/2.